Okay, here we have a differential equation to solve. And the first thing we're going to do is take the integral of both sides. So if we take the integral with respect to x of the derivative with respect to x of y, the integral and the derivative will cancel each other off. And on the left-hand side, we'll just have y. And on the right-hand side, we'll have the integral, the indefinite integral of 7x squared over the square root. And instead of the square root, I'm going to just use the 1/2 power because we often use the power rule. So it's 1 plus x cubed to the 1/2 power, and that is with respect to x. Okay, it looks like this is set up perfectly for u-substitution. Within the integrand, we have an expression and its derivative. Well, not exactly its derivative. We have an expression 1 plus x cubed, and the derivative of x, the derivative of 1 plus x cubed is a multiple of x squared. It's not exactly 7x squared, but the derivative of x to the third power is a multiple of x to the second power. Okay, so if we let u equal 1 plus x to the third power, well then du will equal 3x squared dx. Okay, well, we don't have 3x squared. We have 7x squared. So we need to get rid of the 3. We don't need the 3. So let's divide both sides by 3. But what we do need is a 7. So what we could do is we can multiply both sides by 7. So we're basically multiplying both sides by 7/3. So when we do that, we have 7/3 du is equal to 7x squared dx. So we're going to use this expression for u, that's going to go in, and we're going to use this expression for 7/3 du. And that's going to go in. Okay, so just a little trick. You could eliminate multiplication with division, so we divided by 3, and we needed a 7, so we multiplied both sides by 7. Remember, this is an equation. So you can adjust one side as long as you adjust the other side in the same way. Okay, so when we apply our substitution, we will now have, well, the 7x squared dx, well, that's going to become a 7/3 du. 7/3 is a constant, so let's put the 7/3 out front. And the 1 plus x to the third, all raised to the 1/2 power, that will become u to the 1/2 power. So we'll have 1 over u to the 1/2. So now we have a much more manageable integral to work with. And let's actually rewrite this as 7/3 times the integral u to the negative 1/2 power du. Now we can apply the power rule for integrals, or the reverse power rule. And we will have 7/3 times 2u to the 1/2 power plus c. And the last thing to do is to undo our temporary substitution. So go back to the variable x. So I'll go back to blue. And so that is, well, 7/3 times 2. So we have 14 over 3 times, well, instead of u to the 1/2, we now have 1 plus x to the third power to the 1/2. And don't forget your constant of integration, your plus c. Okay, and that does it for this problem. I hope this was helpful.